Okay, right, welcome back. It seems like a while. We're going to go straight in back with some new content, straight in with some new learning. So do listen carefully. Can you please put a title of instantaneous rates of change and then finding gradients? And we're going to go from there, and hopefully I'll explain what we're going to do during the lesson. Okay, so there's some things we need to know just before we start. There's a few terms we need to know and some information. So if I have a distance time graph, okay, a distance time graph, and the distance, it might be curved or something like that, but the property of that, which you may have learned in physics, the gradient sorry about the phone. The gradient of any point on that line will give you the distance over the time. It will actually give you the speed. Okay, it will give you the speed at any point. So that's the first bit of information we need to know. We also might have a speed or velocity time graph. Okay, again, could be a straight line, it could be curved. And again, from physics here, you might know that the gradient is equal to the acceleration this time, acceleration. And the area under the graph is equal to distance. Okay, so we've got two different graphs there. We've got a distance time graph, we've got a speed or velocity time graph. We could also have, I'm just going to move this down. We could also have any graph that involves any rate of change. So for instance, it could be the depth of a bucket and the time, and the depth could increase and then decrease. You'll see in a question like this in the work I'm about to set. But the gradient here would be equal to, if you worked out the gradient at any point, it would be what we call the rate of change of the depth. Okay, that's just the terminology, the rate of change. And this lesson here is all about working out gradients at a specific point. Okay, so those are the three bits of information we need to know though before we start. So just get those down. Right, if we look at an example now, I'm going to just move that one down a bit. So EG1, this is a slightly easier example. So EG1, find the acceleration of below. Okay, that could be a graph of a car, it could be of anything really, a boat or anything that moves. Find the acceleration of below. Now, you should spot immediately that this is a speed time graph. So the acceleration will be equal to the gradient, okay? And the gradient is rise over run. So now this is a straight line, so I can do that quite easily. Best thing to do is to draw the lines which are really easy to count. So I'm going to go all the way to the end there, and then all the way there, and the rise there is 30 and the run is 6. So the acceleration is going to be the rise, which is 30, over the run, which is 6, which is going to equal 5. And then I need to get the units right. It's meters per second, so meters per second squared, and that would be my answer. Because it's a straight line, the gradient will be 5 meters per second squared anywhere on that straight line. Okay. Right, let's have a look at an example 2, which is slightly more realistic. Now, in reality, you're unlikely to get a situation where there's a straight line of speed to time. It's more likely to be a variable rate. It's more likely to be curved like this. Okay, and this is a rocket is fired upwards as part of a science experiment. The graph of the height of the rocket above ground is shown below. So it's getting higher and higher and higher. It reaches a peak and then it goes down. Okay. There's a few questions I'm going to ask on this. So question 1, find the gradient, or find the rate of change of height find the rate of change of height at, let's say at 3 seconds, okay? So at 3 seconds, find the rate of change of the height. We'll do that one before we move on. So rate of change of height, we're going to find the gradient at 3 seconds. Now the problem here at 3 seconds, if I go up here, 3 seconds, where do I draw a triangle? Because it's sort of a curve. I can't, like the previous question, it's very easy to draw a triangle anywhere because it's a straight line. Here it's a bit more tricky. So what I need to do is I need to draw what I call a tangent at 3 seconds. So I need to draw a tangent at 3 seconds. Now a tangent is a line that just touches the curve and it's straight. And this is where you need a ruler. A see-through ruler is really useful here. And mine's not going to be so accurate, but you're going to draw a tangent would look something like that. Okay, can you see it just touches? You would have come across a tangent in circles, and it works the same in curves. So a tangent just touches the point at 3. And then to work out the gradient at 3, I need to work out the gradient of the tangent. And I do that using, I can draw a triangle at any point there. Again, try and make it easy for yourself. I'm going to say that's about, goes from 24 to about 36. I think that's about 12 high. Again, yours might be slightly different. And then I'm going to get roughly 3 across. Okay. So the rate of change of height, would be equal to the gradient, which is 12 over 3, which is going to be 4, and the units will be meters per second, because on the bottom it's time in seconds. Okay, so that's how you answer those sort of questions. Right, okay, question 2. At what time was the rate of change 0? Okay, so you might see a few questions like this in the homework. At what time is the rate of change 0? So have a look at here. At what time is it 0? Rate of change is 0. This is when the gradient equals 0. And the gradient equals 0 when it's a flat line. So it's a flat line. I'm going to rub this. Flat line. Might be able to copy this actually. Might want to redraw it. It's a flat line here, isn't it, roughly? If I draw a tangent there, it would be a flat line across. So that means the time when the rate of change is 0, or basically at its peak, so that's when it's at its, the rocket's at its highest, it's at 4.5 seconds, and that's the answer there. Okay. Right, the final sort of question is average rate of change. Average rate of change. Okay, now average rate of change. So you might get something for the question like this. Find the average rate of change of the height of the rocket. Now this could also be worded as find the average speed, find the average acceleration. They all work the same way. So find the average rate of change of the height of the rocket between let's say between 1 and 4 seconds. Okay, so find the average rate of change between 4. So this time we're looking at the average between 1 and 4 seconds. So for this question again, quite similar in a way. I go to 1 second, I come up. That's where it starts, and then I go to 4 seconds and I come up. And at this point, I simply just draw a line between the two, straight line, and I work out the gradient of that line. That will give me the average rate of change. So the gradient of that line Now be careful with some of these because they might be negative. All the ones I've done have been positive so far. They could be negative. The height of that, it goes from 12 to about, that's probably about 29. So that's 29 minus 12, about 17 high, and then across we're going from 4.3. So the average rate of change is going to be equal to 17/3, and the units, meters per second. Meters divided by a second there, okay? Right, okay, I think you should be okay with that now. It's just drawing tangents and finding gradients at various points. I want you to have a go at the, it's a worksheet. It's one of the Corbett textbook exercises. It is much easier if you print this off. So if you can print off the worksheet, and at the end of the worksheet, at the bottom of the worksheet, they have a blank graph for you to use for each question. Okay, so do make use of that. And I'll put the exact questions I want you to do on Show My Homework, but I'll be on email as well if you need any help. Well done today, guys, and please can you upload that actually to OneNote so I can check that you're doing this. And any issues, let me know. All right, thanks a lot.